everybody. Hope you all are fine. The topic under discussion for today is the basic concepts about the giants at large, which is divided into two parts. At the end of the session for part 1, the participant should be able to define a giant and list the components of a typical giant, classify giants, describe different types of giants, classify and describe solid giants, that is fibrous and cartilaginous giants, and correlate some of the clinical applications. At the end of the session for part 2, the participant should be able to classify and describe synovial giants, describe intervertebral giant complex and intervertebral disc herniation, and be able to highlight giant mobility versus stability and correlate some of the clinical applications. A giant is an arrangement created between two or more than two bones or cartilages which come in contact so that a definite relationship is established among these components, which can provide liberty to grow and may or may not allow any movement. Structure and function of various giants vary considerably. The basic components of a typical giant are: number one, bones involved, that is articular surfaces and articular cartilages, structure uniting them, that is ligaments and muscles, structures supporting the components involved are the blood vessels and nerves, both bones and structure uniting them are the index of functional activity of that very giant. That is what and up to what extent the movements can take place at that giant. Fourth component, which may or may not be present, is the giant cavity, which is lined with synovial membrane having fluid. First, let us have a view of the criteria for classification of giants. There are two basic principles for classification of giants. Number one is form and structure, which vary greatly, hence classified by keeping in view the biological nature of the components of the giants, mechanical properties of these components, and changes and fate of specialized connective tissue. Second principle is freedom of movement, which varies widely, so that a giant may be immobile and on the other end of the spectrum it may be freely movable. By keeping in these criteria in view, the giants are classified into two main groups, that is solid giants and cavitated or synovial giants. As earlier said, giants are divided into two main groups, solid giants and cavitated giants. Solid giants are further divided into fibrous giants and cartilaginous giants. Fibrous giants have got three groups, that is sutures, gum fosses and syndesmoses, whereas cartilaginous giants are divided into two main groups, primary cartilaginous and secondary cartilaginous. If a giant has got both the components of fibrous and cartilaginous giant, that is classified as a mixed giant. Cavitated giants are the synovial giants. Why these classifications? It is important to know these different types of joints because they each have their own unique range of movements and functions. And understanding them can help better understand how our body moves and functions as a whole. We start with the solid joints, which are also named as syn or trosis. In these joints, connective tissue is present in a solid state. Hence, the nature of the connective tissue between the bones may be fibrous, cartilaginous, or both fibrous and cartilaginous, that is mixed one. Practically no or very little movement is possible in these joints. Their classification depends upon the nature of the connective tissue between the bones. Hence, they are classified as fibrous joints and cartilaginous joints. Fibrous joints, which are also named as articulation fibrosi. In these joints, connective tissue is present as dense fibrous type. These joints are practically immobile and no joint cavity is present. They are classified into three groups: sutures, gum fosses, and syndesmosis. First, the sutures. The articular surfaces in sutures are ragged, and the connective tissue between the bones is present as a membrane which is named as sutural ligament. This ligament makes the joint fixed or immobile. These sutures are present among different skull bones. They are the active site of bone growth. They gradually ossify, and this process starts at about 20 years of age from within outward, and this process is named as synostosis. They are classified depending upon the shape of articulating surfaces and their mode of union. First type of sutures are the plain sutures. Examples are interpalatine and palatomaxillary sutures. Number two, serrate sutures. Example, sagittal suture. Number three, dentate sutures. Examples, lambdoid suture and metopic suture. Number four, squamous sutures. Examples, squamoparietal suture, especially the posterior part. Limbus sutures, temporoparietal suture, especially the anterior part. Number six, wedge and groove or shindylisis sutures. Example, vomerosphenoidal joints. Second variety of fibrous joint is gomphosis, which are also named as peg and socket joints. The opposing articular surfaces in these joints are present as a peg-like process of one bone, which fits into a hole in another bone. These bones are united by ligaments named as periodontal ligaments, which provide firm attachment, but some degree of mobility is allowed. Example is root of a tooth into a bony socket. Third variety is syndesmosis. The opposing articular surfaces are relatively far apart. They are bonded by strong collagenous interosseous ligament, cords, or membrane, and slight degree of movement is allowed at these joints. Example is middle tibiofibular and middle radioulnar joints. Second group of solid joints are the cartilaginous joints, which are also named as amphiarthrosis. The opposing articular surfaces are united by a cartilage that is solid connective tissue. These joints are practically immobile or slight degree of movement is possible. Hence, these joints have got reduced risk of distortion. They are divided into primary cartilaginous and secondary cartilaginous joints. First, the primary cartilaginous joints, which are also named as synchondrosis. In these joints, the opposing bones develop from two separate centers in a single mass of mesenchyme, such as epiphysis and diaphysis. They are bonded by hyaline cartilage or epiphyseal plate. These joints are practically immobile and temporary joints. These giants ultimately unite roughly at the age of 18 to 20, exception being manubriosternal giants. Primary cartilaginous giants are present in the appendicular skeleton. They are finally replaced by bony union, that is synostosis. Hence, they lose growth potential and attain maximal rigidity like bone. Secondary cartilaginous joints, which are also named as symphyses. The articular surfaces are covered by a layer of hyaline cartilage, and they are connected by a thick deformable disc or pad of fibrocartilage, which remains unossified. A cavity may be present in the disc or the pad, but it is never lined by synovial membrane. The gap between the bones is bridged by collagenous ligaments, which never form a complete capsule. The fibrocartilage architecture combines strength with the limited degree of elastic deformability that allows restricted but appreciable movements. Secondary cartilaginous joints are present in the axial skeleton, such as intervertebral joints, exception being symphysis pubis. Majority of these joints are permanent joints. Some end as synostosis, such as between the sacral vertebrae, between sacrum and coccyx, and between coccygeal bodies. Third variety is mixed solid joints or mixed synarthrosis. The connective tissue between the opposing surfaces is partly fibrous and partly cartilaginous. Such joints are present in the skull as certain sutures. To be continued for part 2.